All right, guys, so today we're just going to take a day to review of what we've been working on with slope. I know it says review notes, but I've just left those notes to be consistent and make sure that you guys understand that these practice problems, at least the notes, are showing you again, reviewing, going step by step of what I want you to know, is going to be required and is going to be turned into Google Classroom. Now, make sure that you're doing everything, the entry tasks, including all the steps that I want and steps to show work. So of course, whenever you see this, you should be able to solve all these problems. We've already covered them in past videos or in class. So if you want to press pause, see if you got the answers right, you can do that. I'm just going to go through all these problems to save time on this video. All right, so the entry task, which is the first two columns, say, hey, what is slope and how do you find slope? And again, I am asking you this every single day because I want you to know what slope actually is and what you have to do to find it. Or what is slope is just literally a way to measure steepness. What I mean by a way is a mathematical way. It's a way to put a numerical value to how steep a line is, or other shapes as well on other graphs. Now, the way we find slope is by a specific ratio, which is the change in y, so how far it goes up and down, divided by how much it goes left and right, which is the change of x. So again, this is how we find it. This is what it is. This is how we find that numerical value. That numerical value represents the steepness of the actual graph. Now, of course, we're going to do it differently given different situations. If we have ordered pairs, we need to know what to do, like in problems 5 and 6. If you have graphs, we need to know what to do, etc., etc. And that's my goal for this chapter, to make sure that no matter what representation I give you, you know how to find slope, you know how to analyze slope. All right, so let's start with 3 and 4. Notice that you have two lines here. Just by looking at this, I know this line is going up. If I read it from left to right, I know it's going up, so I know my end result is going to be positive. I know that this graph is going down, so I know that that one's going to be negative. So that's just kind of analyzing the graph before even finding it. So now let's go ahead and find it. So notice I have a line. In order to find the line, again, I need to find the change in y over change of x. In order to do that, I'm going to find an ordered pair on the line that crosses the grid nicely. Now notice that I found multiple spots. Again, it doesn't matter which ones you choose as long as you choose two that are closest together. So just choose two that are close together and go ahead and find your slope. Remember, change in y over change of x. So to go to the left coordinate point to the right coordinate, am I going to go up or down? I'm going to go up. To be exact, I'm going to go up 1 unit. Remember that since I'm going in the x direction, if I go up, it's positive. If I go down, it's negative. Now notice I'm going to the right, 1, 2, 3. And again, this is your x-axis. If you're going to the right, it's positive. If you're going to the left, it's negative. So if I'm going to the right, how many units did I move over? 3. So I technically moved a positive 3. So in order to find the slope, you need to have your rise over your run, which is 3 over 1. Fortunately, I would have to mark up a point because you have to. Oh, sorry, I totally messed up. What did I do there? I put my run divided by my rise, so make sure you are not like me. It's rise over run, and you end up with 1/3, and we cannot reduce this any further. Now, that is all. Remember that when you guys are doing these problems, I want to see a really quick coordinate plane. I want to see the line. I want to see your slope triangle, and I want to see you counting on your notebook. Again, it took me there an extra probably a second and a half, so I feel like you're not going to be spending too much time on that little step. But I want to see the yellow on your notebook to prove you know how to find slope. All right, so let's move on to number 4. Again, the more you practice, the more routine this is going to get. So just to emphasize, notice I am putting multiple coordinate points that this line crosses the grid nicely. Doesn't matter which ones you choose, just choose two that are closest together. So to go to the left to the right dot, am I going up or down? Notice that I'm going down again. And if you're going down in the y direction, it's negative. And this is 3 units, negative 3 units. 1, 2, 3. Then I'm going to go to the positive x direction, 1 unit. So put this together again, your slope is your change in y over the change of x, which is a negative 3 over 1. Make sure you reduce as much as possible. Negative 3 divided by 1 is just a negative 3. So that means that your slope of that line is a negative 3. Another thing that I absolutely want you guys to be able to do is to analyze slopes for their values. Notice that this slope has a negative, which concurs with my graph because it's going down. This one has over here has a positive, so it's going to go up. Notice that this one's a little less steep than this one, which makes complete sense because 1/3 is less than the number 3. Again, what does slope do? Measures the steepness. So when you find that number, don't just find the number, but understand what it is. All right, so these are just an additional problems of what I've asked you guys to do. Once you go over there, you're going to have a practice with a couple more problems again, because this is just really quick stuff. You need to be able to understand it and to be able to find slopes. That way it's more useful later. We use it as a tool to compare things, really. All right, so let's start with these 2 lines. Of course, you're not going to graph these lines. Please don't draw a sketch on your paper, drawing these 2 points and then drawing the line, seeing how much it goes up and over. Remember, that slope is change of y over change of x. How do we mathematically show change? We subtract them. So we're going to subtract our 2 y's and divide it by subtracting our 2 x's. Now notice that I left out my 2's and 1's. It's just to kind of reiterate that. It doesn't really matter which ones you call 1's and 2's, but in every math book, they're always going to have that way too. All right, so let's go ahead and apply our formula. Now, in order to not make mistakes or set me in a position not to make too much mistakes, I always write my formula with the subtracting. I know that this is an x and a y, an x and a y. These are the first ones that showed up. These are the second ones that showed up. So what goes here again? y2. y2 in this situation is 0 minus 1. And then x2 is 2. And then x1 is 0. So all that's left is the math. 0 minus 1 is a negative 1. 2 minus 0 is 2. So my slope is negative 1 over 2. If you were to graph these 2 points, and of course this is random. Let me just not draw the corner points. If you were to draw these 2 points, you know it'd be positive, or sorry, I'm fumbling up this one. So if you were to graph these 2 points, you know that it would be negative, so it'd be going down. How much down would be going? It'd be down 1 and over 2. So there, finally got it. Right, number 6, more of the same. Again, your slope is the change in y over change of x. So notice that here, those are your y's. These are the first ones that showed up. These are the second. So it's 5 minus 1. And then our x would be 0 minus 1. So do the math. 5 minus 1 is 4. 0 minus 1 is a negative 1. If we divide this, it'd be a negative 4. So this one would be going down, and it'd be going down in a way steeper form because the 4 is bigger than the 1/2 and comparing 5 and 6. So, yep, that's pretty much it. It becomes super mechanical the more we practice and practice. All right, so these will be the last problems we cover. Notice that the first 4 problems, or 6 problems, were just about finding slope. It's how to find that slope. Now, these problems are concentrating on how to use slope, because I'm telling you guys, or asking you guys, to graph a line with a slope of negative 4 over 3 that goes through this specific point. Now, if I'm trying to draw a line, I need a starting point. So let's just draw the line through that point, or start with that point, which is x is negative 5 and y is 5. Remember the way I like to do it, I like to just go to my x is negative 5, go to my y is a positive 5, which is right over here, and then I picture where they would intersect if they go forever, and that would be the point. Again, it doesn't really matter how you plot your coordinate points. I don't mind as long as you do it correctly. All right, so let's go ahead and use this slope. It is a negative 4 over 5. Remember, the change in y over change of x. So we can clearly see that our change of y is at negative 4. So if we're at this coordinate point, we're going to go negative 4. So that's down, because when I go down, my y's are negative. I'm going to go down 4. 1, 2, 3, 4. Then I'm going to go in the x direction, positive x direction to be exact, 5 times. 1, 2, 3, 4, 5. Let me count that again. 1, 2, 3, 4, 5. There we go. In this situation, I'm only going to have you guys do 2 coordinate points, so I don't mind if you just do it once. Now, the one thing I do want to see is your slope triangle. Now, I know it might feel annoying, but it's a way to ensure that you guys got it down. All right, and the cool thing about this is you can go down 4 again if you really wanted. 1, 2, 3, 4. 1, 2, 3, 4, 5. The straighter your line is, of course, the more accurate you're going to get to your coordinate point. All right, last one. So we have to go through this point and have this slope. Well, let's start with the point. Here is my x equals negative 5. Here is my y equals negative 6. Here is my point. I notice that my slope is 3. Now, when I look at this and I'm like, okay, I know my change of y is 3, positive 3 to be exact, but what is my change of x? Remember that whenever you have a whole number, put it over 1, because what you're really doing is dividing by 1 3 divided by 1 is still 3. You haven't changed anything mathematically. That means that your change of x is 1. So if you look at the slope, it's going to go up 3. 1, 2, 3, then over 1. You can do as many as you want, at least a minimum of 2, because of course you need a line. I'm not going to require 3 like the past sign. 1, 2, 3, over. And there is your line. So remember that when you do these problems, I don't only want you to just do it, I also want you to analyze, and that's what's going to be our main focus in our next class. Notice that this one's negative, so it's going down. Notice that this one's positive, so it's going up. Notice that this one has a number of 3. This one has 4/5. That means that this guy is way bigger than 4/5. So it's going to be a lot steeper, and we can tell pretty easily in our graphs. So yeah, that's pretty much it. Make sure that you copy these down. You have a homework assignment, just practicing this material, and that's it.